Hello everyone. So in this video we're going to learn about textual inversion technique through this paper, and this was released on 2 August 2022. So quite a very old paper uh, in terms of AI space. This paper actually describes how to personalize the diffusion models, basically the latent diffusion models. So let's suppose you want to actually um, personalize it for specific use case. Let's suppose the text to image model, the latent diffusion model, have the ability to generate any kind of image, but you want to actually generate in a specific style or generate a specific object. So that what basically it tells about that you can actually personalize for a specific use case, for a specific object or a specific style. Basically this technique is about like inverting the process of learning, the diffusion process, injecting a new embedding into the embedding space of a model, which let the model to expand its vocabulary. It gains the ability to generate that specific styles or object. In the abstract you have like they have described using only 3 to 5 images of a user provided concept like object or style. We learned to represent it through new words in the embedding space of frozen text to image models. These words can be composed into natural language sentences, guiding personalized creation in an intuitive way. So here you can like see the examples they have provided. So there's like teddy bear. No, it's not a teddy bear actually, but whatever. So like a backpack. So it's quite a very interesting. Like you can see here, like Banksy art of X Star. Like I don't know what exactly it's, but this is quite interesting. Like themed a lunchbox. So they have like used printed this doll in the lunchbox. That is quite cool actually. So basically the whole deep learning where like most of the things people are doing is like using that for specific use case. So they have the general model and then they try to actually fine tune it and or basically just try to make it personalized in a different ways. So this is like in the industry what doing for the past 2-3 years, because you will going to see that there's lot of big models will come up, but you have to actually personalize for your specific use case, and this paper is doing that for vision models. So in the introduction they have like introduced the concept, like what they're trying to do. That's what I described, like they're trying to personalizing the diffusion model, latent diffusion model to a specific style or the object. So here you can see like this embedding is found through an optimization process which refer to as textual inversion. So in the related word there are quite few methods they have like found to actually do this do this task. Like there's one thing you can do which is like train the model from scratch for just the sake of adding one piece of concept, but this cannot be done easily because it is very hard to actually train the full from scratch, because it's very expensive and requires a lot of efforts to actually do so. Requires enough GPUs and stuff like that to actually do distributed training and stuff. But so the second method is like fine tuning for some blocks of the model, or basically with the new data. So this is called what exactly the fine tuning. The problem with fine tuning is that when you fine tune a specific block or many specific blocks in the model, what exactly happens is like it forgets the previous knowledge. That's what we call catastrophic forgetting. So when it forgets the previous knowledge, you don't have anything left. You can just only generate a specific concept or specific style. So there's no like usefulness in this, because let's suppose it will only actually remember that specific object. Let's suppose the specific styles you're training. So here like they have, that's why like they are trying a new way, it's like textual inversion. So that's the approach is like we show that we can expand a frozen model's vocabulary and introduce new pseudo words that describe the specific concept. So the model has a vocabulary. So model understands the meaning of the words, because model is trained with a huge amount of captions, the images with captions, and model learns to map the captions into the embeddings. So model has the understanding of the captions, the specific words, So let's suppose you when you type something like a photo of dog, the models produces the photo of a dog because it understands the how the dog looks like. So when you have a new object inside the when you are trying to actually customize for a specific object or personalize the model for specific objects, so the model generate that specific object, you introduce that object inside the model, you introduce that the meaning of that object inside the embedding space. That's what you're trying to do. Like that's what they are telling, that they are adding a new pseudo word inside the model's vocabulary, so the model learns, understands that specific object or a style, and able to generate that specific style or object. That pseudo word is basically kind of any like normal word, but you cannot use any normal word. Let's suppose if I say photo of a Harsh, my name is Harsh, so photo of a Harsh, but you cannot use that thing because there's a very different meanings of Harsh. The model will forget other meanings of Harsh and only generate my image when you prompt the photo of a Harsh. So you can use like, you should use a very unique token, like some like people use in mostly people use like XYZ or something like ZWX, so OHWX. So they are using like different kind of unique word, which is basically a token in itself, a single token. So where the model learns that thing, learns the pseudo words, and able to actually generate that concept. That's why they have called textual inversion, because this is the inversion, means the reverse engineering of how the model learns. So the model learns through, let's suppose you have text, the captions, and then the model learns to map the text with embeddings. But here what they are trying to do is like they have the embeddings, which is like a token. You have the token, and then you use that token to learn the specific concept. So you using the embedding to map the text, the whatever text is, let's go XYZ, the photo of XYZ, a photo of HWX, some token. So the original process is, let's suppose you have the name like a photo of a dog, the model learns to map that text and learns the embeddings, try to change its embedding during the learning process. Whereas we have the embeddings, you just try to map the associate the meaning of that word with that embedding. See, the models basically learns the new embeddings, and then when basically the learning process is done, the model has the understanding of that concept. So this is what exactly the textual inversion is about. Here's the textual inversion. Basically, to find the new embeddings, we use a small set of images, like typically 3 or 5, which depicts our target concept across multiple settings such as varied backgrounds poses. We find V star through direct optimization by minimizing the LDM loss. So they are like reducing or basically minimizing this reconstruction loss. This is the reconstruction loss. So in the implementation detail, they have mentioned like they have our experiments were conducted using this much GPUs with batch size 4, learning rate which is like 0.005, quite a high learning rate, but I think it works like you can tune it around like with more or less learning rate. The model actually converges well with number of more images. You can also add more images. 3 or 5 is like something like a baseline for them. All results were produced using 5,000 optimization steps. So basically they are like doing 5,000 steps, 5,000 training steps. So they found like these parameter works well for most cases, but I believe like there will be like very optimal parameters, like learning rate should be quite less, and you can like do with a batch size of 1, because when you have lesser batch size, you can actually the models learn very effectively. You can see like input samples, skull mug you have, and then the photos are these kind of things, looking quite similar but not exactly. So this is the textual inversion techniques, but there's like another techniques have been introduced for the last few years, which is like the one is Dreamboot. Dreamboot is quite a better technique than the textual inversion, but the textual inversion is faster than the Dream Booth. It only trains the embedding layers, and they have various use case in the downstream application. So here you can see like it is actually edit any kind of images. In the evaluation metrics, they are using like clip based distance, so like the clip based cosine similarity between generated images and the images of a concept specific training. In the last you can find like this is a template which is quite useful. Here you can see like a training prompt templates, photo of this, rendering of this, photo of the cool. This is pseudo words. You can replace pseudo words with any kind of thing. So this is all about the texture inversion technique. I hope you understood everything, and please let me know what can I do, what can I improve in this, and how it can be done better, like in explaining different papers. I will also try to upload more videos with explaining papers, implementing papers. And if you are that kind of person who likes to read papers, likes to learn what is happening in the research space and implementing that kind of papers, so please subscribe, and we'll see you next time. So bye.